Good evening, children. So, who are there? Ranindu. Good evening, Ranindu. Ranindu, මේකේ වෙනදා වගේම තියෙනනේ මේ පේන් එක බෝඩ් එක පේන එක මාව පේන එක වෙනසක් නැහැනේ. අපි පොඩි වෙනසක් කරලා තියෙන්නේ. ඔයගොල්ලන්ට කවුලක් නැහැනේ. Ranindu, everything is okay? Okay, thank you. Right, අපි පටන් ගමු lesson එක. Last day we gave some chart of what we are going to do. First we divided This thing, what we are doing, we call it descriptive statistics. Descriptive statistics, and we divided it into two parts, mainly ungrouped data and ungrouped form of data and grouped form of data, right? So when a number of data is relatively small, we take them in ungrouped form, the existing form, without any change in, right? Uh, if the number of data is relatively high, this is what we have to discuss today. We have categorize them before taking into computations. Uh, Ungrouped data, we started this last day and discussed two things. Number one, uh, measures of center. Measures of center. Then after that, we came to measures of dispersion. Dispersion. Uh, the same thing, the similar things we are going to discuss in group form today also, right? Okay, before that, as measures of center, we introduced three measures. What are them? Remember? Oral Bante, Ala, චූට්ටක් ඉන්න ළමයෙක්. Okay. Nanindu ඔළුව හරවලා බලන්න ඒක. අප්සෙට් එකක් නැහැ. Good evening, everybody. Just wake up. Good evening. Right. As measures of center, what do you remember? The things we introduced? The measures we introduced as measures of center? Median, more than mean. Median we introduced as once you arrange the data in the ascending order. Right. Right. Median introduced as once you arrange the data in the ascending order, median is equal to xn plus 1 over 2. Right? Then the mode is mode. Mode is the most repeated data, right? Most frequent data. Most frequent data, right? Most frequent data. And what about mean? Mean defined as x bar, defined as sigma xi divided by n, right? Then we said measures of dispersion. Measures of dispersion we introduce to check how the data are distributed about your center, right? Maybe it's the median you are going to use as a center, maybe it's the mean you are going to use as a center. Then about that, whatever the center, how the data are dispersed, right? Dense, whether the data are dense or they fall apart, more deviated from the the center value, it is to check that we introduce measures of dispersion, right? So what's it better? The data are more dense about the average or the center, or they are like more dispersed, uh, falling away of the center. The more reliable the center is when data are dense about that, right? So measures of dispersion, they have to be always small as possible, right? The smaller, the better. So if median is what you're going to use as the center, then to check how the data are dispersed about the median simple M, we introduce quartiles Q1, Q2, Q3, and sometimes you use dectiles, dectiles D1, D2 up to D9, sometimes maybe percentiles P1, P2 up to P99. These are used to check the dispersion of data about the median. Okay. Uh, Q1 we define as xn plus once the data are arranged in ascending order. Q1 is xn plus 1 over 4. Q2 is as same as the median, so it's xn. It is xn plus 1 over 2, and Q3, the third quartile, yeah, this is called the lower quartile, the middle quartile, upper quartile, or the fifth quartile, second quartile, third quartile, right? So the third one, or the upper quartile, is given by x 3 or 4 n plus 1, right? Then these are the measures about the median. Then about the mean, to see how the data are dispersed about the mean, we introduce again several measures. First is the variance. Variance denoted by PARX. It's defined as, remember, sigma of xi minus x bar squared over n. Then standard deviation. This is also denoted by sigma squared, right? And the standard deviation denoted by sigma, it is just the square root of variance x. And right, then we introduce the mean deviation. Mean deviation is mean deviation. We denoted by dx, which is defined as sigma of mod of xi minus x bar divided by n, and coefficient of variance we denoted by Vx or maybe Cv sometimes used to denote this. There are no standard notations for these. These are standard, right? Notations you see everywhere in books. This one, but not these. We wrote capital M for this. So we wrote a Vx for the coefficient of variance. It's defined as sigma over x bar, usually given as a percentage, right? And do you remember last time we said this is used mostly to compare two distributions, which is more stable, which is more reliable to check, right? So more reliable or more stable is the one with if we are going to compare two distributions, find Vx for the first, say Vy for the other, then more reliable is or more stable is how to compare. So we said earlier also, the smaller, the better. Once it's connected with variance, right? Here again, the smaller, the better, right? And yeah, these are the measures we introduced, defined to find the distribution of data, distribution of the dispersion of data about the mean. We did one example, only one example, and we go back to that computation and the example. Uh, Especially define variance. We constructed table. The table we had several columns, xi, then xi minus x bar, then it's squared, many things, right? Fortunately, in that problem, x bar was, you remember, you have it. X bar was 9.9. Then x minus x bar values are relatively simple with only one decimal place. What if x bar was something like 9.92? Then down the line, the column xi minus x bar values will be of two decimal places. Squaring them, things could have been much more difficult. So if you had three decimals here, uh, yeah, the least is better. This particular. Uh, uh, in that problem, x bar was just 9.9. The things were easy for us, right? Say it was 9.92 or 9.917, things could have been much more difficult, right? Then to make computations of variance, and also x bar. X bar for that particular problem was easy to find. The values were very simple. 7, 8, 9, 10. How many given? 7, 8, 9, 10, 11, 12, 13. Those are simple values, but don't expect them everywhere, right? So with much more complicated values, the computations can turn up some more harder, right? Then to make computations of especially x bar and variance x, and also sometimes the mean deviation. To make computations of these things easier, we are going to use two theorems, right? Now we are going to learn two theorems which make us easier to compute, especially x bar and variance x. Uh, this one also කියන්නේ මේක මහා කරදරයක් නේ. අලුතෙන් සිලබස් එකට දාලා තියෙන එක. ඉස්සර තිබුණේ නැහැ. ඔකෙන් ලොකු වැඩකුත් නැහැ. ඒ වුණාට ඒක හොයන හැටි පොඩ්ඩක් ඉගෙන ගමු. Okay. මමත් වැඩියම දැකලා නැහැ ළමයෝ මේ රනිදු මේ mean deviation එක කොහෙද පාවිච්චි වෙන්නේ කියලා මමත් වැඩියම දැකලා නැහැ. හැබැයි ඒක මම ඔයගොල්ලන්ට තේරුම් කරා why it is introduced. The reason is when you find xi minus x bar values, so we have x bar. ආපහු බලන්න මේ table එක අපි හදමු. The particular example that we have taken last day. When you write xi minus x bar, above x bar and below x bar is a table xi minus x bar. Above values are negative, below the values are positive. බලන්න table එකේ above 10 in the table values are negative, below positive, right? And you said the smaller the better the variance. But what can happen here is you can get big negative values and big positive values, but ultimately cancelling each other, you can get a nice small value for the variance, right? Theoretically, it can be zero. So that can mislead us. Then we have to avoid getting negative values of finding xi minus x bar. To avoid negative values, we have two options. What are them? Xi minus x bar getting negative values, we have two options. One is to square it. The other is to take the mod. Taking the squares, we define variance. Taking the mod, we define. Taking the squares, we define the variance. Taking the mod, we define the mean deviation, right? In the kata hitanna square in the values, even the units will be squared. Millimeter na millimeter square kilometer the kilogram na kilogram square there are effects. One might argue to minimize the effect. Why don't we use the absolute value? නිසා එහෙම දෙකක් තියෙනවා හොඳේ. ඇහුවොත් ඒකත් හොයන්න මේකත් හොයන්න. But mostly hereafter mostly you see we build the theory upon the variance and sigma. X bar variance, those things very rarely. Even I have seen where I use the mean deviation. ඒක හොයන්න ගියොත් හොයනවා. අපිට එච්චර තමයි තියෙන්නේ. ඉදිරියේදී යනකොට මම දැකලා නැහැ වැඩි පාවිච්චි. Right. So we are going to learn two theorems which help us to compute x bar and variance x much more easily, right? The following two theorems. Help us to compute x bar and variance x much more easily, right? Okay, theorem 1. Theorem 1, we are going to give an equivalent expression for the variance. The definition our definition for variance x is sigma xi minus x bar squared over n. මෙතන කරදරේ වෙන්නේ once you find xi minus x bar, you might get decimal values. Squaring them, things can be worse, right? You can avoid that using this theorem. So I gave you the definition and I gave you last day an example also. After learning this theorem, you will never use the definition, right? The last example I gave only to understand the definition, but hereafter we are not going to use it. Instead, mostly it's the theorem, the other expression that we are going to see now is what we are going to use to find variance. Not this, right? Maybe we are not going to see it again mostly, right? Because the theorem gives us a much more simpler expression. Theorem 1 is variance x is also, again equal to sigma xi squared over n minus x bar squared. In this, you don't face that problem. Xi minus x bar giving small decimal values, right? So this is most of the time, this is much easier to use to compute the variance, right? Than our previous expression in the definition. We'll do the proof. Proof. Proof මම කිව්වා නම් ඔයගොල්ලෝ තනියම කරන්න පුළුවන් වෙනස් ඕනේ. පන්ති හිටියා නම් මම දෙනවක්වත් කියනවා. දැන් මට තේරෙන්නේ නැහැ මොනවද කියන්නේ කියලා. ඒක මම කරමු. Yeah, how to start? By definition, variance x is sigma xi minus x bar squared over n. Because it's a proof, better we write. I go from 1 to n. Okay. Ideas are welcome. What do you do next? Expand the square. From 1 to n. What is it expanding? Xi squared minus 2x bar xi plus x bar squared divided by n, right? Now keep in mind, x bar is something we computed earlier. The mean, it is a constant, right? X bar is a constant. Okay, now the next step. Yeah. Uh, Break it to three parts. So then you get as one part sigma xi squared over n. Sigma xi squared over n. So it's part of the expression that we need. Now that comes on to second thing, right? We have already got one part. Then coming to this, then you take this part separately. What do you see? Yeah. 2 and x bar are constants. You can take them out of sigma. So that will give minus 2x bar sigma xi over n. Next, give 1 to n. 2 second give 1 to n plus the last part x bar square as a whole is a constant. You can take it out of sigma. Then leaving only inside sigma, leaving only inside sigma 1 and divided by n. Right? May I know any? Apit one any? I know the something. यहाँ पर बार बार करने के बाद sigma x squared over n. Right? Minus 2x bar and look at this. Now, how do you? Yeah, that's again. We know x bar. That's x bar. Uh, that's x bar. Then plus x bar squared. What is this? 1. Sigma of 1 as I go from 1 to n. That produces n. 1 plus 1 plus 1 n times. That will give just n divided by n. Yeah, that gets cancelled. So finally, you are going to get sigma xi squared over n minus 2x bar squared plus x bar squared and ultimately sigma squared over n minus x bar squared. So exactly what we needed. Right? The proof is easy. They sometimes ask these proofs, right? කටපාඩම් කරන්න ඕනේ නැහැ. පොඩි ටික අදහසක් තියන්න ඒලාට ගන්න පුළුවන්. The example we have taken last week, we named it example 1, right? දාන හදන ඇටි මම ඒක කරන්න වෙන්නේ ටේබල් එක ආයි ටේබල් එක ගන්න. Yeah, now you need in your table you need only two things. Yeah, xi and xi square. Another people values chamber. Yeah. Table again. 7, 8, 9. Square them very easily. Take 20 seconds. 49, 64, 81, 100, 121, 142, 169. Now what's in? Yeah. 1009. So it's very quick, right? You can find this squares very easily, very quickly. Then variance x is equal to sigma xi squared n minus x plus squared. It's 1009 divided by n is 10 minus x bar squared. X bar is 9.9 squared. What is it? 100.9 minus 9.9 squared. 90.01. අද කැල්ල ගොඩා ගන්න පුළුවන් නේ. ඔව් ඒක මැනික් හොයනවා වගේ කැල්ලකේ ඉලක්කම් නෙවෙයි මන්ද. Right. Our again, it's 2.89, isn't it exactly the same as what we found before? But this is much more quick, easy, right? It's easy to find it this way. Did you find it? Right. Right, using the theorem. What if we had instead of 7, 8, 9, 10, what if you had say numbers like this? 111, 112, 130. Now, we saw that using the theorem, computations were easier for that particular example. But what if the data were like this? 97, 98, 99, likewise. Now what do you see? It looks it's like no use for the moment if things are like this. Squaring them is not much more difficult now. Right. So the theorem, that theorem is useful only if the numbers here are relatively simple, right? If the numbers are much more bigger or much more complicated, maybe 3.124 is one data, 3.171 is the other data. So we have another theorem, the second theorem. Using the second theorem, we will convert these numbers into simple numbers, more simple numbers, right? We are going to use a substitute. Okay, if the numbers are like this, so you see that using theorem one is again not easy, right? So theorem one is practicable, useful only if the numbers are much more simpler, right? If numbers are like this, to convert them into much more simple values, we are going to use the second theorem. In the second theorem, we will convert these numbers into much more simpler values by a substitute, right? Converting, we are going to convert data into simple values. Okay, theorem 2 is for that. Theorem දෙකම එකතු වුණාම තමයි අපි මේ ඉගෙන ගත්ත දේ ප්‍රයෝජනයක් තියෙන්නේ. මේක විතරක් නැත්තම් පේනවනේ. අර පොඩි ගාන හදන්න ඉතුරුනාට අනිත් වෙලාවට ගොඩක් අමාරු වෙන්න පුළුවන්. So you need to use both the theorems, right? Theorem 2 says, in theorem 2, we introduce a substitute. Theorem 2, if two random variables x and y are connected by a relation like this, x equals a y plus b. Or the idea is this: we have data, a distribution of x. As we have seen, I explained, the x values are not that simple, right? And we want to convert into simpler values. So what we do is we introduce a substitute y equals x. We subtract something from each x to make it smaller. Okay, we subtract some b value from each x value to make the value smaller, and you can make them even smaller dividing by some a. Okay, doing this, we convert x values into much more simpler values, right? Which can be handled easily, right? Uh, where a, b are, we decided two constants a, b to get simple values for the variable y, the substitute y. හරිනේ පොඩක් හරි දෙන්නම් example එකක් බලමු තේරෙයි. Where a, b are two constants. Okay, if two random variables are connected this way, x equals ay plus b. Now we know that the y values are simple and computations of y are easier. So you can easily compute y bar variance y because the y values are much more simple, right? Okay, suppose that you found y bar, easily found y bar. Then how to convert it into x bar? X bar and y bar are connected by what? If x equals ay plus b, the theorem says you just multiply y bar by a and add b. If you can find y bar easily, then just multiply it by a and add b, you will get x bar. What we wanted to find. Okay. Or you can easily find say variance y. You can find variance y easily. How to get variance x from this? The theorem says you just multiply variance y by a square. A square. Variance y multiplied by a square will give variance x. You can forget this b, right? B plus b will not affect the variance. ඒක නිකන් හිතා ගන්න පුළුවන් නේ. මේ බලන්න. X is equal to y plus b. මොකද වෙන්නේ? Variance එකට. Each y value will be shifted a distance b. Y plus b. Each y value will be shifted a distance b. Then the variance, will the variance change? Variance කියන්නේ how the data are dense about the mean. ඒක වෙනස් වෙනවද? ඔක්කොම values ටික පැත්තකට ගත්තොත්. ඒකට y භාවතෙත් ඒ විදිහටම distribute කරලා තියෙනවා. Right? So this constant b, adding a constant will not affect the variance, right? But of course, the mean is affected. The mean changes with the addition of a constant. Okay? දැන් මේක නිකන් කියලා හරියන්නේ නැහැ. අන්න අර අනිත් එක ඒකටත් අපි ලියමු. මේක ලොකු ප්‍රයෝජනයක් නැහැ මෙතන ලියන එකෙන්, right? Mean deviation. Mean deviation, I like dy for that, dx. You find dy easily, just multiplied by, you can guess, to convert into mod of a. Again, this will not affect, multiply by mod of a to convert into dx. With the proof එක කරන්න ඕනේ. මේකට ළමයි නමකුත් කියනවා. If you use it as a method to compute, then you will call it the coding method. Right? Coding method කියන්නේ මේකට. Coding method කියවම නිකම්නේ code කරනවා. Coding method. Code කරනවා කියන්නේ තේරුම දන්නවනේ. Code කරනවා කියන්නේ එකක් වෙනකොට වෙන එකක් ලියන එකනේ. නේද? Coding and decoding. Now proof එක කරගෙන. Okay. Let's do the proof. Proof of one. You want to find x bar. X bar is equal to, by definition, sigma xi over n. As this goes from 1 to n. Okay, you have some idea? Yes? How to start? Yeah? Okay. Yeah, replace xi by, we have to substitute. Exactly. AYI plus B. From 1 to n, we want to convert it into y. So we replace xi by AYI plus B. And the next step, come up here. Next step, you can easily see now. The rest, make it into. At the same time, time to take A out is a constant. A sigma xi over n plus B. B is a constant. Taking it out will give sigma of 1. 1 to n divided by n. So these get cancelled. And what is this? Another one? It is A. This is it has to be y. Continuously. It is y bar plus b. So it's very easy. The proof. हम देने का क्रम को by definition variance x. I'm going to prove this. Not I am going to prove. We are going to prove the second variance x. By definition, it is sigma xi minus x plus square over n as it goes from 1 to n. Right? Yeah, another current. Substitute for xi. So xi you substitute 1 to n. Xi substitute what? AYI plus B minus what about x bar? Yeah, x bar we have already proven that it is equal to here AY bar plus B and whole thing squared divided by n. Now look at this closely. What do you see? Yeah? B get cancelled and moreover A is common. You can take it out. You come out as A square, yes. Then you can take it out of sigma because it's independent of I. So that will give taking A squared out sigma of yi minus y bar square divided by n. Then this is nothing but variance of y. So A square into variance of y. That's the proof of the second. तो मैंने कहा तो हम करो एक पिक्चर हमारे में dx we defined as sigma of mod of yi minus y bar over n. You know नहीं? Yeah. What is the next step? Substitute for yi. Yi is dx में लिया नहीं xi minus x bar over n. Substitute for xi AYI plus b minus AY bar plus b mod of that divided by n. Now what do you see? B gets cancelled. Again, A is common. You can take it out, but will come out as mod of A. Mod of A and the view sigma mod of yi minus y bar. Yi minus y bar divided by n. मैं अंदर ना में dy mod of A dy. හරි මේ තේරම් දෙකම එකට ගත්තාම තමයි අපිට it's practicable right ඔක ලියා ගන්නකෝ අපි ඊට පස්සේ බලමු කොහොමද කියලා මේ ප්‍රූෆ්ස් අහනවද කටපාඩම් කරන්න ඕනේ නැහැ පොඩ්ඩක් තේරුම් ගන්න කල්පනා කරලා ලියා ගන්නවා මේ ප්‍රූෆ්ස් අහනවා Right, go to an example. We are going to use the same example that we have taken earlier. Now remember that we introduce a variable y. We introduce a variable y. Given a variable x, we introduce a variable y, a substitute, such that we can. That means we decide a constants a and b, such that the y values are very simple, right? To get in order to get very simple values for y, we have to decide the values for a and b. We are going to the same example that we have done before. Use theorem 2 to find x bar and variance x bar, variance x and dx for the distribution above example 1. In above example 1, right? Then earlier we constructed the table of xi values. X values are 7, you said 8, 2 9s, 3 10s. Make on the Raga 11, 12 and 13, right? Now we are going to introduce another variable y. Y values we want as simple as possible. To get y as simple as possible, from x we subtract something that we decide and divide by some other constant. Just tell, what do you like to subtract from these x values to make y as simple as possible? But the best values to subtract from these x? Yeah? Subtract to make y as simple as possible, yeah? What give me a gun? Vattila says 2, Ranindu says 10. Any other idea? Any other?
5.
Yeah?
5.
5. Rashain says 10. To get as simple as possible for the values of y, what is the best option? Take something from the middle. Through above that you get some simple negative values. Below some small positive values. Then 5 that will raise up to 8. Yeah, today was 8. Right? Then if you take 10, what the minimum negative value is? That will be just 3. Yeah, negative 3. Positive, the biggest. If you take 10, positive biggest will be again 3. So that's the best option. So you subtract. Yeah, 10 is correct. Suggested by Ranidu and Rashid. What will the not 2? It's 7. Yes, yes. I saw 7. 2 ki me metan inna kawura hari. Metan inna kenek wage 7 da pega man dakka. But again, that's not the best option. 10 is the best. So we will subtract 10. What I know? Now forget this for a moment. That this A. For B we take 10. Forget A for a moment. If you just subtract 10 from each, what are the values? What will be the values you get here? This will give y value 0, 0, 0, then minus 1, minus 1, minus 2, minus 3. Below 1, 2, 3. Right? Can you ask anything more? This is the simplest, right? That you can ask for. Then what about A? Divided by something. Not to spoil it. Just take 1. A equals 1. Okay. So your x is 1 into y plus 10. Then there another right? We decide A and B in order to get the simplest possible values for y. Whenever I am done with the already very simple. Already the simplest. ගන්න පුළුවන් සාමාන්‍ය ගම්ම මොකද වෙන්නේ? වෙන වෙලාවට පුළුවන්. මෙතනදී ගන්න බැරි නෑ. මෙතන ගත්තොත් වැඩි. වන වෙන එකයි වෙන්නේ. නේද? වෙන වෙලාවට හරි. You have to decide. Okay, 1 1. Okay. 1 is accepted. Then අපි ඕනේ කොට බලා ගන්න ළමයි. To find you just find y bar. You find y bar and then you can convert it into x bar, right? So to find y bar, you need sigma yi. Sigma yi, you need to find sigma yi to get y bar. So you can easily find it. Just add them up. Then to get, you will find variance y, and then convert it into variance x is by multiplying by a square. To find variance y, see the theorem 2, theorem 1, the previous theorem. You will need yi square, the column for yi square, then add them up. This will give sigma yi, another column to find sigma yi squared. තව කරදරකාරයෙකුත් ඉන්නවනේ නේද? මේක හොයන්නත් එපා. dx and you will have to find dy first. For which you need yi minus y bar. At the same time, can't you take the modulus of that? Take up tooling. Equal function ටික පුරවලා දැන් තේරුණා නේද තේරෙන්න එක? දැන් ඊට පස්සේ හැම තැනම වගේ මේ theorems එක පාවිච්චි කරනවා හරිද? We don't just use the definitions. Using definitions, you see the calculations are, computations are much complicated. Sigma yi, you get just minus 1. Line. By the To fill this, you have to find y bar first. Find y bar equals sigma, sorry, y bar equals, yeah, sigma yi over, and sigma yi is minus 1 over 10, that's minus 0.1. මෙහෙම එකක් තියෙනවා මම මේ theorem එක පාවිච්චි කරලා මේක නම් අමුතෙන් ලේසි වෙන්නේ නැහැ. දෙකම එකයි. තිබුණ එකම තමයි. You get the same values here. මේක ලොකු වාසියක් වෙන්නේ finding dx or dy using the theorem. නෑ මම ඔයගොල්ලෝනේ කියන්නත් හදලා කිව්වේ නෑ වචනයක්. මේ මම මේක හැමදාම කියන නිසා කියන්න හොඳ නැති වෙයි කියලා හිතලා කිව්වේ නැත්තේ. මීට කලින් ඉගෙනගෙන තියෙන ඔක්කොම දේවල් අමතක කරන්න. මම පාඩම අයන් ඉඳන් උගන්වනවා පටල ගන්න එපා කිසිම දෙයක්. ඕලේ පන්ති ඉගෙන ගත්ත දේවල් පවා පටල ගන්න එපා. හරිද? අපි මේ theorem එකක් අපි we are using properties of variance x and x bar. We used properties of them. හරි එච්චරයි. වෙන මොකුත් නැහැ. මොකද මේවා තව ඇඩ්වාන්ස් ඇප්ලිකේෂන් තව උඩට ඔයගොල්ලෝ ඉගෙන ගන්නකොට පාවිච්චි වෙනවා. ඒ නිසා වෙන කිසි දෙයක් එක පටල ගන්න එපා. හරි? වෙන ඔක්කොම දේවල් අමතක කරලා දාන්න. මේක හරියට තේරුම් ගන්න. ඔක හැමතිස්සෙම කියන නිසා මම හිතුවා අද කියන්න ඕනේ නැහැ කියලා. මොකද මේ ලොකු පටලැවිලි කර ගන්නවා ළමයි සමහර දේවල්. සමහරලාට නොගැලපෙන දේවල්. කොහොමත් එකයි හා xi minus x පහවත් y minus y පහවත් එනිසා මේ theorem එක ගන්න කියලා මේක අමුතෙන් ලේසි වෙන්නේ නැහැ නේද? එක මේ වයින්නේ නේද? කම්පියුට් කරනකොට මේ ඔක්කොම එකට කරන එක ලේසි නේ එක ටේබල් එකේ. මෙතන ඉන්නේ 3.1 හැම එකේ 2.1 නෑ නැත්නම් මෙතන 2.9 2.9 එක දුන්නානේ minus y minus y ini 1.9 gitu ya 0.9 next kan ada guys minus plus 0.1 ini 0.1 0.1 1.1 2.1 and 3.1 6.6 9.6 9.6 10.2 13.2 isn't it 13.2 or not? What is it? Ito wala boleh kan ni. Udah game බලනවා ගේ මේ ටිකක් තමයි කැල්ලේ. Okay. 13.2. No, that's the trouble. We're going to know. So now you can easily find x bar. Sorry, y bar, right? Y bar we already found. Then convert it to x bar. How? This is y bar. X bar is, the theorem says, a y bar plus b. So what is a? A is 1. Okay, either is good. Y bar 0.1 plus b. What is our b? B is, I think, 10. So it's 9.9. It's the same value as we got earlier, 9.9. Definitely racing, I mean, 40 values. Now we put the example as we say. Dahan dulu, sampai kapan kalau kan jadi decide. Sama ini ting kapan kalau dapat dah ada nih kan dua nak, dah ada nama kerja nama kalau pian. Then find variance y. Variance y is given by. Ane nama ni whole element ni hoga nama kami ni. Kata pada kata kini ya. Ni terung anda ni whole element tu bukan nama kita. Kata kata ni. Ini sigma y squared over n minus y bar squared. This is by theorem 1. Sigma y squared is 29. 29 over 10 minus y bar. Y bar is minus 0.1 square. What is 2.9 minus 0.01, 2.89. Kaling nga lagi. Come on. This time it's the computations are much more simpler than the previous computations without the theorem. Make dy is equal to sigma mod of yi minus y bar over n, and we found it 13.2 divided by divided by 10. It's 1.32. Then to convert it into dx, the theorem says you have to multiply this by mod of a. Mod of a dy. This is the theorem. Mod of a is in this particular problem. A we have taken. What is our a? It's 1 into dy. Dy is 1.32. It our name 1.32 dx. දැන් තේරෙන්නේ තේරෙන්නේ නේද? ඊට පස්සේ දිගින් දිගටම අපි පාවිච්චි කරනවා. Right. So it's like we discuss everything under ungrouped data, right? Ungrouped form of data. Now, next we are going to start grouped data and convert the things we discussed so far, everything, right? Everything we discussed so far into the group form or to make adjustments of the things. Nanti kami lah, aduannya dah. ඊළඟට group data. Group data. Group data. The thing is, there are two cases again here. So earlier we said if the number of data is relatively small, you take them in ungrouped form into computations. And we said if the number of data is relatively high, we group them before taking into computations. But grouping them, again, there are two ways, right? Again, here, I put a few right here. If the number of data n is relatively high, we group them before taking into computations. So there are two ways of grouping. There are two ways of grouping. Two ways are number one, forming frequency tables. Forming a frequency table. Number two, forming a class frequency table. Or frequency distribution कर लिया हमको. Forming a frequency distribution or a class frequency distribution. Then we can start from the first. Calculators තියෙනවනේ නේද අපේ? දැන් තමයි ටික ටික ඕන වෙන්නේ. නැද්ද? ගෙදර ඉන්න ළමයි කොහෙන්ද එකක් හොයාගන්න තියෙනවා නේද? මම නිකන් හිතලා ගණන් දෙන්නේ ඕක ටිකක් ලස්සන නැති වෙලෙත් දෙන්න පුළුවන්. විභාග ගන්න බා calculator එක කරන්න ඊට පස්සේ කිය calculator එකෙන් දෙන්නේ ඒකට අවුල් Hari, shall we start from the first? When frequency distribution is formed, when do you decide to go to just a frequency table, not to divide the data into classes, not into classes. You just like categorize them without forming classes. It is like this. if you have a considerable number of data, right? You are not going to take them in the ungroup form. Number of data is relatively large, but the varieties, the different types, the different values of data, that's relatively small. So you have 300 data, but they are, you can easily identify, say, in 5, 6, maximum up to 10 categories, 10 values. එකයි කන්නක කම්පැනි එකක් තියෙනවා. අපි කවුද? පුතා කට්ටියක් දානවා කියන්නේ ඒ කවුද ළමයි? කවිෂා. නේද? කට්ටියට මතකයිද නේද? ඔව් කවිෂාගේ ෆැක්ටරි අපි හිතමු වැඩ කරනවා 300ක් මිනිස්සු. Have 300 workers from the owner to the laborer, right? So if you are say collecting data about say the salaries, wages of the workers or employees, yeah, we don't have to watch an Indian of the employees, you get 300 number of data. It's big, right? You can't take those data in a group form, so you have to group them 300 data, group them before taking into computation. But 300 data, yes, you have 300 data, but what about the varieties? Will there be a big variety in the wages in a company? I mean, you don't see normally 20, 30 or bigger number of varieties. භවිෂ්‍ය ලෝභ නිසා පටි ගෙවන්නේ නැලු මන් දන්නේ. හරි ඒක කමන්නේ. මොකද සාමාන්‍ය කියන්නේ මම කියන්නේ the stages, levels. Do you expect many levels in a company? No, usually lowest, maybe laborers, then come to say it's a garment factory. Laborers, then supervisors. Maybe mechanics before that, laborers, mechanics, number 2, number 3, supervisors, then come to sometimes maybe assistant managers or directly managers, then directors and the owner. හතක් තමයි categories. තව වෙනවා ක්ලාස්ලා ඔපරේටර්ස්ලා එක්කම එක දානකට දාන්න පුළුවන්. ගොඩාක් එන්නේ නැහැ. Right? So you have 300 number of data, but you can categorize them into only some limited levels. So in that case, you don't need to form a class frequency table as we have seen in OLS. That correct? Class frequency tables, right? It's enough. You just take xi values and their frequencies, xi values. Right. If the number of data is relatively high, but there is more again, but the number of levels. So you got the number of levels. Is small. We group the data, we form a frequency distribution. Frequency distribution of the form. It will look like a frequency distribution will look like company the wages. So the wage, number of people getting the particular salary. So x1, x2, x3, say xr, xm, xm calculator. Then the number of people in that category, right? Say F1, F2, how many laborers are there? How many supervisors are there? And company group නම් මේ කට්ටිය ගොඩක් වැඩි. ඊට පස්සේ මේ ටිකක් අඩුයි මේ කට්ටිය ඉන්නවා. අඩුයි මේ කට්ටිය ඉන්නවා. අන්තිමට උඩට යනකොට මැනේජර්ස්ලා ඩිරෙක්ටර්ස්ලා අයිතිකාරයා මැනේජින් ඩිරෙක්ටර් වෙනකොට එන්නේ අඩු වෙනවා. කම්පැනි එක පොඩි නම් මේ පල්ලෙහාම ඉන්න අයට වඩා පවුල කට්ටිය ඔක්කොම දාගත්තාම ඇමති මණ්ඩලෙ හොයාගන්න බැරිය. මොකද වෙන්නේ? මේ පැත්ත ලොකු වෙනවා මේ පැත්තට වඩා. පවුල කට්ටිය දාගන්න ගියාම මොකද තමයි ඉන්නේ. So FRN, FN, right? Pwede na. Pwede. Mga idea na. May kaya hindi. O may na pa mga idea na. Ha? O may mga idea po sige na. දැන් පේනවද? දිනින පත්‍රේ හෙඩ්ලයින් එක ගන්න උඹත්. ඔව් දිනින පත්‍රේ හෙඩ්ලයින් එන ෆොන්ට් සයිස් එක. මෙතන මේ හට යවලද? ඔව් නේ. මෙහෙට ගන්න ඕනේ නේද? මේක ලයින් එක. හරි මම දැනෙන්න දෙන්නේ. මොකක්ද ප්‍රශ්නේ? මම එහාට ගිහලා වැඩිනේ. I'll draw this again. Oh. ඇතුලෙන් එන්න. අපි කරමු. මම ඔබතරාට මයික් එකෙන් ඉන්න. කියන්න වේද ළමයි? මේ අපිට තේරෙන්නේ. දැන් ෂේප් නේද? අපි දැන් මේ මොකක්ද ප්‍රශ්නේ? දැන් හරිද ළමයි? දැන් පේනවද? දාපුණට හරි. දැන් මේක නම් හරි නේද? දැන් පේනවා. දැන් හරිනේ. Right now, if the things are like this, how to find the center? How to find the measures of center, then measures of dispersion? How to adjust the definitions to this situation? But ලියාගන්න ඉස්සෙල්ලා. Right. Now, let's see how we adjust our definitions. Means first, find measures of center. Okay, now few things are easy. Now for frequency distribution, idea. You can guess, you can easily not guess, you can easily decide what do you take as the mode. Mode is the thing you can most easily, yeah, mode is the one with the highest frequency. You just go through this frequency line and find the xi value with the highest frequency. Yes, mode is the xi value with the highest frequency. Accuracy, highest frequency. Number two, median. Median, how to find the median? median, the definition will not change. Uh, the definition will not change. Earlier we defined it as xn plus over 2. It will remain the same, but the way you find it will be little different. You have to. You will need another, uh, not row. It's more column. For the cumulative frequency. එක මම ගණන් හදනකොට එන්න right. Cumulative frequency. මේක මේ frequency කියන වචනේ මට කියන්න බැරුණා. මේ මම මොනවද කියලා නේද? Frequency number of times each data is repeated. මේ frequency කියලා ලියමු හොඳ නෑනේ නේ. Frequency, right? Median remains xn plus 1 over 2, but the way you find it is a little different, right? Adding another, in computations you will draw this vertically, right? As columns, you will need to add another column for cumulative frequency, but the value will be the same, right? Why not possible? Then make a mean x bar. What do you mean? Earlier we just had x1, x2, x3, each data appearing sync, right? Then we just added them to get the total into the bulk, the whole bulk, and divided by number of data. Now the thing is, x1 repeats f1 times, so its contribution is x1 into f1. We have f1 times of x1, so for the total bulk, its contribution is x1 into f1. Then what about this? x2, f2, x3, f3. So you add them up. That is also sigma xi, right? Calling give it sigma xi. This time you are not writing x1 f1 times. x1 in your table. It will not be repeated f1 times. Instead, you just write x1 and the frequency. So it's like you are adding x1 again over and over again f1 times, which gives x1 f1 times. Similarly, plus x2 into f2, x3 into f3, right? So generally, taking together, in short, it is you find xr fr for each xr value, then add them up, and then divide by the total number. Total number is given by total number of data is given by sigma fr. So that's the adjustment, but it's like nothing in this. It's the same as we wrote before, right? The notation. So this is how we adjust the formula that we use to find measures of center. Then what about measures of dispersion? Measures of dispersion. Of dispersion. Remember earlier, our x bar was just sigma xi over n. Right? Now under the new situation, we adjusted it to sigma xr fr over sigma fr. We just rewrote it. Right? Now our previous definition for variance x, sigma xi minus x bar squared over n. Now, how to adjust it? Matching to this new situation. Instead, you have you are not writing xr minus x bar, xr minus x bar, xr minus x bar over and over again. Instead, you can multiply it by x bar. So each will be with an r given I o r into u, right? Each will be multiplied by fr and be divided by sigma fr, right? Oh, we had another expression variance x. We wrote another expression sigma xr square or I on an idea में और बोलूँ तो idea में idea I में बोल देंगे I write I everywhere sigma earlier we wrote sigma xi star over n minus x bar square. How to adjust this for this new situation? Yeah, sigma fi xi square multiplied by fi and instead of n you will write sigma fi. So that is the adjustment. Hmm? Then dx, but we have to create mean deviation. Earlier we wrote sigma mod of xi minus x bar over n. What is the adjustment here? Multiply everything by fi. Instead of n, you will write sigma fi. එතකොට මේවා මොකද වෙන්නේ? අනිත් තාපේනවනේ. Sigma x standard deviation. Earlier we defined it as root of variance x. Any adjustment needed? No. Somehow you find variance x, then just take the root of that. I'll do sigma x. No change, right? No adjustment. Vx earlier we defined as coefficient of variance. We defined as earlier we defined this as sigma over x bar into 100. Any adjustment needed here? Somehow you find sigma, somehow you find x bar, then just divide them, multiply by 100, you get the same. So no adjustment, no change in this, right? No change in this. අනිත් ඒවා වෙනස් වුණා. 4 times ඒවා බලන්න බෑනේ. මට ලියන්න එක මදිද? ඔය ටික ලියන්න නම් අපි 4 times ඒවා ලියන්නත් බෑ. Start from this side. Start from this side. You know 4 tiles left tiles ඒවා ලියන්නේ. ඔය ටික ඉස්සෙල්ලා ලියා ගන්නකෝ. Are they clear? Then quartiles. Quartiles should apparently it will not change, but the method of finding it will have some difference. Quartiles, the definition will be the same. Q1 is x n plus 1 over 4. Q2 is equal to median x n plus 1 over 2. Q3, the upper quartile, x 3 over 4 n plus 1. Dectiles, D1 similarly it will be x n plus 1 over 10. And I will leave D3 x 3 over 10 n plus 1. Percentiles, never the heavy line, what you can understand? The other way more. Percentiles, P1, P3 will be x 3 over 100 n plus 1. P31 1 x 31 over 100 n plus 1. Other ball may over there. We can start with calculate the thing. අගාන් ලියන්නකො අපි මේක හදන ගමන් ඉගෙන ගමු. ඔයගොල්ලන්ගේ 2011 ප්‍රොටෝටයිප් පේපර් එක නැද්ද අරගෙන? ඒක තියෙන එකේ මේ probability statistics ගන්න ටික ගොඩක් හොඳයි. ඒ ටික ඔක්කොම යනවා නම් හරි පාඩු දෙනකොට නැතුව ඇති. දැන් මගේ නම් මේක සොෆ්ට්වෙයාර් එක තමයි. අර ඒක කියලා යන්න මේ දායි. ගන්න ලියාගන්න. So we will have to construct a table again. Oh, අදරෑ කීය වුණත් මේක ඔක්කොම හදලා ගන්න. ඔව්, ඒ 12 වුණත් හදනවා. මොකද අනිත් දවසේ වල ඊළඟ දවසේ අලුත් ටොපික් එකක් පටන් ගන්නවා ක්ලාස් එක. right month එක කරගෙන යමු. මේ ටේබල් එක මම මේක තියෙනවා. ටේබල් එකට මේවා එන්න ඕන ළමයි. හරි කල්පනා ගන්න දැන්. Alright, Balagan, to find x bar, variance x, mean deviation dx, we need to introduce a substitute. Use theorem 2, coding method Q enable. Can you suggest a y value? Y defined as y plus x minus something divided by something. B and A. Yes? What would you like to take as B? Yeah? To subtract from these xi values, what's the best? Something in the middle. Yeah. 65 is okay, good. Then divide by. Okay, we just subtract 65. See the values you are going to get will be just subtracting 65. It is 0 minus 20 and minus 35. Make you know 15 and 55. Still thick. You can make them somewhat smaller, dividing by 5. Yeah, divide by 5. So dividing by 5 that will be minus 7, minus 4, 0, 3, and maximum is 11. Yeah. Right? These are yi values. Then to find variance by, you need yi squared. Yi squared. Then balance these two expressions to find variance by. To find y bar, you need fi yi. Right? Fi yi. You need sigma of fi yi to find y bar. Right? Then to find variance by, you will need fi yi square. Sorry. Yi minus y bar. If you multiply for the dx, then multiplied by fi. Fi into mod of yi minus. Now make over then we divide everything. Then finally, to find quartiles and the median, deciles, those things, you will need a new column, capital F, we name page 9. Column page 9 mod of yi minus y bar fi into mod of yi minus y bar and finally a column for capital F, cumulative frequency. After we define the cumulative frequency, what is the cumulative frequency? Right, capital F cumulative frequency का मैं मेहमाई define करने आप एक cumulative frequency is this. Frequency is the number of times the data is repeated in the particular category, right? In the particular category, how many items you find in that category, right? Cumulative frequency is the number of items up to that level. Okay? So up to 30, how many data are there? Up to 30, there are just 13. 13. Up to 45, how many are there? Up to 45, everything. 13 plus 25. The total up to 45 is this 13 plus 25. That will be 38. Then that is the cumulative value, right? And up to 32, that will be 38 plus 32. Here, 70. Then up to this, 93 and 104. The metric pura kan FIYI minus 91 minus 91 minus 100 0 69 and 121 itu sudah kan. Then xy yi square. You just multiply these two. If you look, you know, 91 into 7. What is it? 137. No, 637. किधर में करो? मतलब 200 0 107 yi minus y bar है ना y bar होएगा ही पहले सिग्मा xy y है मतलब क्या देंगे इसमें किसी सिग्मा होएगा ही नहीं मतलब क्या देंगे ना पता ना this one where is exactly 0 huh? minus 1 minus 1 ne? It's like negligible getting minus 1 TPS से कहना तब से कहेगा minus 1 तो लोग करके आना रहा मैं monthly में ओलर मैक्स वाली में बढ़िया no trigonometry no calculus just add subtract multiply तो y bar है ना भाई बनते हैं so y bar is sigma xy yi over n sigma xy yi is minus 1 over 104 ये देने का minus 0.0 9 96 करूँगा itu kita aku mau karena direct kerana ओटी एडजस्टमेंट टैग करो मुझे रास्ता में के अभी जान उदाहरण के कर दे मैं बोली वेरी सर मैं वहां थोड़ा कर दे रहा ओटी एडजस्टमेंट टैग करो का कनेक्ट करो ओटी करा ये हाथ लगाने मैं कर सीए के करा ना चला change it to 21 कितना मिल रहा है 21 कितना I make it change it to 21 मेरी कोई तरफ में से ये वाला नेटवर्क है 21 into 11 231 तो make 30 अरे तो मतलब that again into 21 itu dia लगेगा 4000 कम make maybe 2000 2541 dan naik kelas kan mah itu kita ni deh 40 109 itu nama nanti tu एक पूरी वैल्यू ना मांगे क्या बना सकता है अंडर 9 किसी भी this time plus अरे 109 or 104. This time will be 1.01. No, 1 point, around 1.08. 05 down here. 1.05. Then make out the parameter. yi minus y bar, then take the one, making yi minus 1.05 and b minus 8.05. What is plus? What take the sum 8.05? Okay. 5.05. Internet 1.05. 1.95. 9.95. जो maybe वही करा रखते थे अब फिर देखो नहीं दिया खाली करा रखे मतलब 104.65 मतलब this into 25, right? 125, 26.25. मतलब 32, 33. Hari, मतलब 5.75. मैं sorry 23. Hari 40. Then this into 21. 208. 108. 108. 200. 209 के दाम लो approximately 209 त्यामुळे ठीक आहे तू करायला लागते काय थोडे उदाहरण ने नेगेटिव 3785 make और ना make One and three. 53. Make either again. When away. Should be close to 500. Close to 500. And 18 point. 35. Eighteen point. And 18.35. දැන් ටේබල් එක හදුවම පස්සේ අපිට කොහොම උත්තර හොයාගෙන යන්න පුළුවන්. ඔය ටික ඉවර කරගන්න ළමයි. ටේබල් එක හැමෝම හදලා ඉවරද ළමයි? කවුද ඉන්නේ? කවුද ඉන්නේ දන්නේ නැහැ. වතිල රණිදු තව කවුද ඉන්නේ? රෂෙන් ඉන්නවද? Have you completed the table? Oh. එහෙනම් itu ටික කරගෙන අනිත් අය කවුද? කවුද ඉන්නේ? Completed the table or not? ඔයගොල්ලෝ හරිද? මෙතන ඉන්න හැමෝම. හා? ඒක තමයි calculator එක කියන්නේ. නැත්තම් වෙලා යනවා. හරිනේ. දැන් ඉතින් වාගේ we found y bar. You know how to convert it into x bar. X bar is a y bar plus b. A is 5, isn't it? Y bar is 1.05 plus b equals 65. So the period in May 725 70. Right. So let's find variance y first. Variance y is sigma f5 yi squared over n minus y bar square. Sigma f5 yi squared is, it's a big number, in 3785 over 104 නෙවෙයි දැන් මෙතන. ඉතින් මෙතන මේක වෙනස් වෙනව නේද ළමයි? ඔව් නේද? this is not 104 නේද? නෑ. 8.05 වල ටිකක් මේ ටික වෙනස් කරනවා නේද? එහෙනම් කලින් එකම ගන්න වෙනවා නේ. ඔව් කලින් එකම ගමලම නැත්තම් y bar වෙනස් වෙන හැටි මේ ඔක්කොම වෙනස් කරන්න වෙනවා. එහෙනම් කමන්නේ කලින් එකම මෙතන ගියතුනේ බලන්න. බලන්න. ඒක 104 නේ. ඒකට මේවා වෙනස් කරන්න වෙනවා. ඒක 120 බලන්න. ඔව් මට වෙන්නේ ගෙදර ගහගන්න. මේ ටික වෙනස් කරන්න වෙනවා. 121 level. ඔව් ළමයි ආයෙ වෙනස් කරන්න වෙනවා. sorry. නෑනේ ළමයි y bar වෙනස් වෙන හැටි මම කියන ඔකේ ටේබල් එක හදලා තියන්න අනිත් දවසේ අපි ගාන ඩිස්කස් කරමු. හා? මම නිකන් පැහැදිලි කරන්නම්. මෙතන එනම් මොකද අලුත් 121 කියලා ඔයගොල්ලෝ මේ මොනස් දෙක අලුතෙන් හදන්න. මේ දෙක මේකම කපනවා. මේ දෙක අලුතෙන් හදන්න. එච්චරයි හැබැයි අනිත් වෙනසක් නෑ. ඔව් අනිත් ඒවල ප්‍රශ්නයක් වෙන්නේ නෑනේ 104. මෙතන මොකද වෙන්නේ now the total is 114. හරි. ඒතර මෙතන මේවා වෙනසක් වෙන්නේ නැහැ නේද? නෑ හරි. හරි ළමයි ඔක ඔයගොල්ලෝ ගෙදරදී හදන්න අපි ළඟ දවසේ ඩිස්කස් කරමු. දැන් කොහොමද වෙලා ඩිස්කස් කරමු. එතකොට මෙතන තියාගන්න කීයද? 21. 21 තියාගෙන හද ගෙදරදී. 114 එතකොට මේ ටික වෙනස් වෙයි. අලුතෙන් ඔය ටේබල් එක ගන්න. අලුතෙන් ගන්න හදන්න ළමයි ආ. අලුතෙන් ටේබල් එක හදන්න. ඊළඟ දවසේ පටන් ගන්න එක අපි හදමු. මම හිතන්නේ කරන දේ තේරුණානේ ඔයගොල්ලන්ට. මම අර බොහොම චූටි වැලියු එකක් ආවම අපිට ගොඩක් කරදර නිසා වෙනස් කරේ. ඒකට හරියන්නේ ගෘටි වෙනස් කරේ නෑ. ඊළඟ දවසේ හදමු you keep 21 here right. හදාගෙන ඉන්න අපි අනිත් දවසේ පන්ති පටන් ගන්න හැටි ඒක ඩිස්කස් කරමු. keep it 21 here. කල ගෙදරදී හදන්නකෝ. Right, okay, discuss කරලා ඊළඟ දවසේ බලමු how to do computation with class frequency tables. හරි එහෙනම් ළමයි අද ඔතනින් නවත්තමු. ඕක ගාන හදලා තියන්න. ඔක්කොම ඉවර වුණාම අපි ෆාස්ට් යූස් කරන් ඩිස්කස් කරමු. right, එහෙනම් හැමෝටම good night. Good night.